Step 7 has several tools you can use to get information about the PLC. We're going to start Somatic Manager using the Start menu this time. And when Somatic Manager opens, we'll have our last project that we were working with automatically come up open. And I'm going to click on the project folder level just to show that when we go to the PLC menu, we're wanting to do a thing called module information. But at the project level, that's grayed out. And the reason we can't use it from the project level is because you could have actually multiple PLCs or CPUs within a project, and just from that level it would not know which CPU we were wanting to get information about. So you either have to click at the hardware folder or at the CPU folder itself. Either one will work just fine. And once you select that, you can go to PLC and module information is active. So we click that, and it opens an online window with some general information about the CPU. Gives the part number, shows this is a 315-2 PLC. The firmware revision is 3. It's in rack 0, slot number 2, and the module is present and OK, so everything is working correctly. From here, we can go take a look at memory, and we have two bar graphs that show the amount of memory that's available and how much of that's been used. See, we have a light green color in the bar. That's the free memory, which in this case is just about everything. We have a small blue line across there at 1% showing used memory. If we had a bigger program, it would be a larger blue section. We're typically interested in looking at work memory. That's the memory in the PLC where the actual executing program resides. In this particular CPU, we have 64K of memory, or 65,536 bytes of memory. We've only used 50, so most all of it is still available. And this is the place where we can come in and easily check how much of that memory has been used. If you ever get a message that says you're out of memory or memory's running low, even though you realize the program is much smaller than what you've got, you want to come here to module information and compress the memory. Now, compressing memory gets rid of any older versions of blocks that are still laying around in memory and closes up holes and gaps, and gets it where you can load a contiguous large block into memory. We can click the Scan Cycle Time tab, and this will show us how our PLC scan time is running. We have a line graph showing from minimum to maximum configured scan time. And we have a green line showing there that shows our current time. If we click Update, that'll always show what the last seen scan time of the PLC was. Looks like we're pretty consistent around 1 millisecond here. If we click the Communication tab, you see that we're using the multi-point interface MPI network at 187.5 kbaud, which is the maximum rate. There's also a thing called the C-bus, or communication bus, available, and that goes across the backplane from the CPU to any modules in the rack that need MPI communications. And it's also running 187.5 kbaud. Just like MPI. We're using about 20% of the capacity of the communication channel right now. We have a connection to the programming device and also to an operator interface. Performance data is where you can look and see what the capabilities of a given CPU are. If you don't know the memory capacity, the I/O capacity of that particular CPU you're connected to, coming to module information, performance data is the easy way to find out what's available for that particular CPU. If you're not sure about I/O, you see we have our inputs and outputs laid out here. The inputs run from I0.0 to input 127.7. It's a byte.bit format there, so we have 1,024 bits available. Same with the outputs, 1024 going from Q byte 0, bit 0 to Q byte 127, bit 7. And for our memory bits or control relays, we have 2,048 of those, 128 timers, 64 counters, and there are the address ranges for those. Then we also have a thing called local memory, or local data. That is memory area that's used to pass information between blocks of the program or used for temporary storage in the block. If we want to see what particular program blocks are valid for this CPU, because it does vary depending on the model CPU, you can click there on the button and see the blocks come up. These are the organization blocks that are available, and it gives you the function or the thing that makes this organization block be executed, things like cyclic interrupts or communication errors. We also see the system functions and system function blocks that we noticed earlier when we looked at accessible nodes. This particular model CPU has 54 system functions. You have a number, a name, and a comment to tell you what that system function does for you. And we have 7 system function blocks with their numbers, names, and comments. Remember, these are stored in the firmware of the PLC, so they're built into the PLC. We also tell you at this point how many functions, function blocks, and data blocks are available, the numbers, and the maximum length in bytes of each block. So you could have 127 data blocks, each one 8 kbytes long. We can close this and go to our time system. The time system tab shows our current date and time. Now, we may not be using that for control, so you wouldn't think we'd care whether that was correct or not, but we do, because there are some diagnostic buffer messages, things like warnings and just informational messages that get their time and date stamp. The diagnostic buffer pulls that PLC clock, time and date, and stamps its messages with that, so we want to set that correctly. I've set it here several years in the past, so we can obviously see that it's wrong, and we need to set that correctly by going to the PLC menu and picking Set Date and Time. When that comes up, if we want to take the easy way out, we can just pull the clock that's being pulled from the programming device or the PC that's attached or we're running step 7 with, and hit apply, and that moves the PC clock over to the PLC clock, synchronizes them, and we say OK, and go back to our taskbar and pick our module information again. You see that did not automatically update because it was already running. If we hit the update button, though, it shows the current date and time right there on the screen. So now we know that the PLC clock has been read. We can look at our diagnostic buffer and start looking at some of the messages we can see there. The PLC stores 100 diagnostic messages in this buffer, and real handy thing about this is it cannot be cleared by a user. You can power cycle, do whatever you want to the PLC. You don't lose these messages. So if you have a situation where you're getting reports of strange things happening in the wee hours of the morning, you can come in and look in this buffer the next day and say, oh yeah, at 3:27 a.m. this morning, yes, the machine did stop because someone moved the key switch from run to stop. That would cause it. So again, that can't be erased or cleared out, so it's always there for you to go back and look at. It does have 100 entries in there, and once you hit past 100, it drops the oldest one off and starts putting the newer ones in its place. You see, we do get the time and date stamp down to the millisecond on each one of these events that come in, and we get a little information about it. Down below in the window, we get some more detailed information, which you can scroll down into. This says details of event 1 of 10 because we've highlighted 1 above. If we clicked a different message or event number, we'd see his information. What I've done is flip the PLC from run to stop and back to run here, and we hit update to see those messages get pulled in. And you see right there it says the PLC stopped because the stop switch was being activated. And as you move from message to message, you see the details change down there. If we need some more help, we're not sure what that meant, click the help on event and it says, well, CPU is in stop because we set the selector there to stop. Kind of hard to argue with that. And then you can see also as we go on toward the lowest number event, that's the last one that happened. You see we went from stop back to start up with the key switch, did a warm restart, and then went back into the run mode, and everything went back to normal at that point. So like I said, we do have that. We can update it again. I've done a power fail this time. I turned the power off. We're still waiting just a second for the CPU to finish its diagnostics and get communication going again. Now we see at event number 5, we stopped with a power failure. And then event 4 shows the power came back on just a few seconds later and went back through the startup routine. So our previous messages just got shoved down in the buffer, and the most current events go down at the lowest number. You can click the settings button if you want to filter what you're seeing there. If you don't want to wade through all 100s, if we want to get rid of all the stop events, we can uncheck that box and just get rid of or select only certain classes of events that we want to look at. Make it a little easier to see what's going on. We've gotten rid of the stop, say OK. Now you see we only have event number 2, and number 7 was when we were coming back into run operation. So these had nothing to do with the stop part of the problem. And you notice also the number showing is only 2 and 7. So if you ever come into this diagnostic buffer and you don't see all your consecutive numbers, click the settings and make sure the filtering hasn't kicked out some of them that you might want to see. You can close the buffer now and actually close the project out with step 7, and that's everything we need to see about the diagnostic buffer.